Servomex, the global expert in gas analysis, offers a comprehensive range of solutions for carbon capture and storage. Carbon capture and storage technologies are used to collect carbon dioxide emissions from power plants and heavy industry, transporting it by pipeline or ship for underground storage. These captured CO2 emissions can be used to manufacture fuels, carbonates, polymers, and other chemicals, contributing to a circular economy. This is known as carbon capture and usage. CCS and CCU can be categorized by the method and placement of the carbon capture technology, which falls into three main types: post-combustion capture, pre-combustion capture, and oxyfuel combustion. Post-combustion capture involves CO2 capture from the flue gas of a combustion process. The flue gas is cleaned to remove trace components, such as sulfur dioxide and hydrogen chloride, that may interfere with the capture process. The gas is then purified, most commonly with a molecular sieve, to remove water vapor, carbon dioxide, and gaseous hydrocarbons. Then, various capture mechanisms, or a combination of them, can be applied. These may be phase separation, elective permeability, or the most common mechanism, sorption, which uses chemical and physical solvents to remove the CO2 from the gas stream. Post-combustion capture requires gas analysis measurements at the indicated points. Pre-combustion capture uses a group of technologies to remove CO2 before the fuel is combusted. This requires a carbonaceous fuel to be broken down into hydrogen and carbon monoxide, which is known as syngas. For efficient CO2 capture, this syngas has to be shifted after cleaning, creating heat and a gas stream with high CO2 and hydrogen concentrations. The CO2 can then be removed using solvents, adsorbents, and membranes. Again, gas analysis measurements are required at the indicated points. Oxyfuel combustion is based on denitrification of the combustion medium. Nitrogen is removed from the air using membranes or a cryogenic air separation unit. Combustion thus takes place with nearly pure oxygen, resulting in a flue gas containing mainly CO2 and water. The water and any trace impurities present are then removed. Once more, gas analysis measurements are required at the indicated points. Servomex provides a wide range of gas analysis solutions for key process measurement points across all these carbon capture methods, providing emissions monitoring, quality control, safety, and combustion control. Incomplete combustion leads to higher carbon monoxide production, excessive dust and smoke, sulfur dioxide and oxides of nitrogen, or NOx, when excess oxygen is present. The ServoPro 4900 multigas is an extractive analyzer that can measure up to 4 flue gas components in a single chassis. This means that, generally, only one analyzer is needed for most continuous emissions monitoring gas analysis requirements. The 4900 multigas can analyze SO2, NOx, CO, CO2, and O2 in the stack prior to the flue gas emitting to the atmosphere. Key measurement locations include the flue gas from the power plant and flue gas to the stack. Since CO2 is useful in the manufacture of fuels, carbonates, polymers, and other chemicals, its quality post-capture requires close monitoring. If captured from a process such as coal-fired power generation, it can contain traces of contaminants like sulfur dioxide and hydrogen sulfide. The quality measurement is made after CO2 is captured in the stack or after the methyl diethanolamine outlet, before transport to the CO2 user. Servomex's ServoTough SpectraExact 2500 photometric gas analyzer is a key solution for this application. In combination with a back pressure regulator, it offers an accuracy of plus or minus 0.2% between the range of 80 to 100% CO2. In addition, depending on the required accuracy, impurities of CO and SO2, and depending on range, H2O could be provided. Other solutions include the ServoPro MultiExact 4100 multi-gas analyzer for trace CO2 and O2, and the 4900 multi-gas for trace SO2. Trace O2 and lower traces of H2O can also be measured using the ServoPro MonoExact DF310E. Apart from the rugged SpectraExact 2500, all these analyzers must be installed in safe area locations. Together, they deliver a range of gas measurements that support the post-capture quality of the CO2. To ensure safety, it's necessary to monitor traces of H2S and H2O in pipelines to avoid sweet and sour corrosion. Monitoring of CO2 and O2 in ambient air is also required to keep personnel safe in enclosed spaces around the pipeline or storage, and to detect leakage. In closed environments, which allow sampling, the ServoTough Oxy 1900 paramagnetic oxygen analyzer can be used for O2, while the Spectra Exact 2500 provides a hazardous area solution for CO2. The Multi-Exact 4100 can be used for O2 and CO2 measurements in closed environments which allow sampling and are rated as general purpose or safe areas. Installation points for these analyzers are the same for each method of capture, so the selection of the technology used depends on the process environment. The Oxyfuel reaction relies on the oxidization of fuels with near-pure O2 rather than air. While this is a good strategy for reducing emissions, it can be expensive and more of a safety hazard. Excess O2 is required to ensure that there is complete combustion. However, too much will reduce the combustion efficiency due to increased heat loss to the atmosphere. Conversely, if there is too little O2, the combustion efficiency will fall dramatically, and CO and other hydrocarbons will be emitted. Continuous gas analysis is essential to optimize the excess air at the minimum level required for complete combustion. Servomex's ServoTough Flue Gas Exact 2700 Flue Gas Analyzer provides a solution for this application. Traditional zirconia technology cannot often be utilized for Oxyfuel excess O2 measurement, as the technology can typically only measure up to 21% oxygen. However, the Flue Gas Exact 2700 can be modified to operate at a range of 0 to 50% O2, even with the zirconia reference being exposed to instrument air. Safety concerns are addressed by the analyzer's integral flame traps that protect all routes back to the process. The Flue Gas Exact 2700 also uses a thick film catalytic sensor optimized for CO to detect parts per million levels of combustibles and monitor breakthrough, the point at which the process runs out of O2 available to fully burn the fuel. Go to servomex.com now to find out more about our range of solutions for your carbon capture process.